Good morning, everyone. I hope you all are doing well, having a great Sunday. So today we'll be talking about forces, and this is the first topic on forces for year 12 syllabus. This is about equilibrium, and we will go straight into the problem because I will discuss important aspects of this problem as we go along. So something important to consider, we will need to draw a vector diagram, and one thing to note, there will not be any resultant. Okay, so no resultant. Why? Because in order for this system to exist, in order for this object not to move, sum of forces, okay, or the net force must be equal to 0. Therefore there is no resultant force. Okay, so once again, our vector addition, we will add, remember, the head of the vector to the tail of the vector and so on. Okay, so let's go straight into the problem. I will move up and draw the vector diagram. Okay, so let's say this is the weight force that is moving downwards, and then I have the force that is on the x direction, which is the horizontal force, and then my tension vector. Okay, please keep in mind that I am adding my vectors head to tail, and none of the tails and the heads are clashing. Okay, so from there we will determine our angle. Now in the example, we are given the angle 60 degrees, that's from the ceiling. Okay, but since our triangle is forming below it, so we will use this angle theta here. Okay, and what is that angle? In order to find that angle, we can either do 30 plus 60, which is 90. If you want to do the other way, you can do 90 minus 60, which gives you 30 degrees. Okay, so that means this theta is equal to 30 degrees. Okay, so this theta over here is equal to 30 degrees. Okay, now we want to find this tension and the force in the x direction first. So let's say A, and I want to find tension first. So how will I do that? So the side that is given is the adjacent side with respect to this angle, and this side here is the hypotenuse. I hope all of you know how I came up with those sides. The longest side in a triangle, in a right angle triangle, is hypotenuse, and the side adjacent to the 30 degree or the reference angle is of course adjacent. Alright, so working on that now. So this should be then so toa. So I think this is cosine theta. Okay, cosine theta is adjacent over hypotenuse, and cosine of 30 is adjacent, and the adjacent side is 30 newtons, and hypotenuse is d. So in order to solve this, okay, remember, since 30 is divided here, so I'll take the t to the other side, this will be multiplied. Okay, so that means this is tension multiplied by cosine of 30, and this is equal to 30 newtons, and I divide both sides by cosine of 30, divide both sides by cosine of 30, and so tension is equal to 30 divided by cosine of 30, and I believe the answer, let me just press it, it's 34.64 newtons. So it's 34.64 newtons. Okay, so that is the value for tension. All right, now let's work on the force. So part B, I'm finding the force in the x direction. So this side is the opposite and we are given the adjacent. Okay, that means this is tangent theta, or TOA is opposite over the adjacent, and since tangent is given as 30 degrees, the opposite is the force and the adjacent side is already 30. In order to solve for this F, you take the 30 and you multiply to the other side. This is 30 newtons multiplied by tangent of 30, and you'll get a force of 30 times tangent of 30. Tangent of 30, you get 17.32, so you get 17.32 newtons. That is the force in the x direction. So these are the solutions to that example. There is another way you can solve this. If you have a different triangle, I give that challenge to you. If you can make a separate triangle, a different triangle, or use different angles to come up with the same answers, please do let me know in the comment section. And if there's something that you did not understand in this video, please let me know and I will make another video to address that issue. And that's all. We have looked for the tension and the horizontal force. That's all on equilibrium, and we will discuss more of these in the future videos. So have a great day and I'll see you in the next one.